All right, guys, how you doing? First of all, I have to apologize. I left my headset at school, and so when I write on this, you're gonna hear the clicking noise of my pen on the screen. Anyway, here we go. Number 11. We'll try to run through this as quickly as possible to make it as fast for you, but at the same time, I'll give you lots of details. You've hopefully have already read the problem, but 30% of the wells are drilled to find adequate water at a depth of 100 feet or less. A local man finds water by dousing using a forked stick to indicate where he should be drilled. You check with 80 of his customers and find that 27 have wells that are less than 100 feet deep. What do you conclude about his claim? Well, what we're interested in is we are interested in P equals the proportion of wells that are less than 100 feet deep. Okay, and the rural area, we know that there's 30% of them are less than 100 feet deep, but this guy thinks he does a better job, okay, with his stick. What a guy. I'm going to make my pen a little bit thicker here. Let's see if I can get this. Go there. Okay, so what we've got is we're going to do a 1 proportion Z test. As we talked in class today, labeling the test is always a good thing to do. And my initial claim or hypothesis is that P is equal to 30%. And this fellow thinks that it should be greater than 30% because for whatever reason with this forked stick he can do a better job. So we're going to test that. Now what's our evidence? Our evidence here is the sample of wells that he did, the 80 wells that he found, and that would be P hat was 27 over 80 or 33.75% of the wells that he found were less than 100 feet deep. So the question really is, and I'll write it over here, you don't have to write this, so I'll put it in parentheses. Did this happen by chance, or is he really good? Question mark. That's what we're really asking, isn't it? Because if he's really good, then he actually does better than 30%, or did he just happen to get 33% when reality is 30% of the time we get wells that are less than 100 feet deep. Okay, well, let's go from here. Well, in order to do this test, for the P hat distribution to be approximately normal, I have to have conditions satisfied. So let's check these conditions. And the 3 conditions that I have to check are: 1, my sample must be random. So the 80 wells random? We're checking with 80 of his customers. Okay, now it doesn't really say that they're random at all. Can we make that assumption that there's enough of them that they're representative of all of the wells that he checked? Well, it doesn't even say that it's all of his wells, so we're going to make that assumption. So we're going to say we assume that 80 wells are a representative sample of all the wells. Okay. Secondly, okay, we have to check that N 80 is less than 10% of the total of the population, total number of wells. And is that reasonable to assume that there's over 800 wells? I think that's pretty reasonable. So we're going to say that's reasonable. And 3. That's why oftentimes we say conditions. Sometimes we call them assumptions, because we're making assumptions. And in real life, if these assumptions aren't reasonable, then we really can't do this test. So thirdly, NP and NQ have to be greater than 10, so 80 times 0.3375 is equal to, and I've got my calculator here, 80 times 0.3375. Actually, that's p hat. It's not p hat. I'm thinking confidence intervals here. It's NP. So 80 times 30% is 24, is greater than 10, and 80 times 0.7 is 56, is greater than 10. So it's okay to proceed with the test. Okay, well, here's my test. I want my z-test. Oops. Well, let me draw my picture so you can see what we're doing. The test consists of looking at the p-hat distribution. I know what the mean is. The use of p-hat is 0.3, and the standard deviation of p-hat is the square root of 0.3 times 0.7 over 80. And my sample is 0.3375, and I'm really asking, what's the probability that I get a sample of wells greater than that? That's my p-value. That's what we're looking for. Okay. Well, what's a z-score? This is a must equation to have. It's 0.3375 minus 0.3 over the square root of 0.3 times 0.7 over 80. And that's going to give me the p-value of what? I'll go up here. I'm going to do that on my calculator. And if I do that on my calculator, let's see what I come up with here. Stat test 1 prop z test, and I get a z-score of 0.7319 and a p-value of 23.2%. Okay, so that means I've got a 23.2% chance of getting water in wells less than 100 feet deep if the population percentage is 30%. That's reasonable. I'm not surprised about that at all. So here's my conclusion, and conclusion is a must for these. Since actually, and the problem, let's look at the problem and say this. I think does it say in the problem what it says? It says we consider a p-value 5% to represent strong evidence. Okay, so this is my, in the court of law, beyond a reasonable doubt, since the p-value equals 23.2% is greater than 5%, this is not evidence that the percent or the proportion of wells with water less than 100 feet is greater than 30%. Okay, that's my HA is greater than 30%, right? So let's recap. Since the p-value is greater than 5%, okay, this is not evidence that the proportion of wells of water less than 100 feet is greater than 30%, because this is reasonable. You would expect this to happen. It's not surprising. And so I don't have evidence to say otherwise. Okay? Does that make sense? Okay, there you go.